Hi, everyone. Good morning, evening to everybody across the globe. Thank you so much for taking out time and joining this conference. It's my pleasure to be here with this audience. I am Minati Mishra, Director, Security Center of Excellence, Philips. I have over 2 decades of experience in development, designing, and securing products. I have also established the offensive security team and also lead the defensive security team with the sole focus on having security built in during the product development phase. So let's go on to the agenda of this talk. So the focus would be, the context setting would be the current healthcare scenario. What is the future healthcare going to be like? What are the associated cybersecurity threats with the future scenario? And what's our way forward? Now, I've been always thinking I can take my credit card anywhere across the globe and do the needed transaction with the credit card. But if there is an emergency and I get admitted to a hospital in an emergency situation, the hospital does not have access to my health records. And that's the situation we are in healthcare. In healthcare, every health event becomes a system of record with the motive of event and giving the necessary billing information, which it does fantastically well. But what is missing is the health journey of the patient being noted so that the patient can give a holistic view of what's happening with him to the doctor. And it's not only for the patient, but even for the clinicians, it's a problem because for every analysis, they have to reach out to various systems, devices to get a complete picture of the patient. So neither is the doctor nor the patient happy, and nor is the outcome very optimum. And this situation is just going to get more and more complex with more and more devices coming into foray and more systems and more systems of records being created. This has to change. From a system of records, we would transition to a system of engagement, which basically talks to the system of records and gives a seamless view to the central person of the entire journey, that's a patient. Healthcare in the future would be centered around the patient. Sorry for the clicks here. Yeah, healthcare of the future will be centered around the patient. The patient can decide which hospital he needs to go without worrying if his health records are following him or not. He can decide to adjust the records, and he basically takes more ownership of his health. With so many monitoring device in place, there is almost 24/7 monitoring of a patient's own health being done. Now let us see in this ecosystem, what are some of the key elements? The first one is IoT used in medical devices, which is also called IoMT. We'll have massive adoption of IoT devices in the medical field. And rightfully so, because there are so many possibilities for having IoT devices in this field. You would have heard of the intelligent pill cam, which can be consumed as a pill. And this pill has a camera, which can basically go through your colon and detect very early stage of colon cancer. Amazing, isn't it? And such kind of application with IoMT devices are massively possible in this industry. The next thing is cloud. Now, IoMT by themselves really would not be able to unleash their potential. Their real potential comes when they all talk to a central backend server, in this case, mostly the cloud, which has then the power to do a lot of extra processing on the data. The adoption of cloud is going to be there and is going to be increasing at a rapid pace. And as we speak, Philips also has created the health system of engagement, which exactly moves from a system of records and gives the user a system of engagement view. The next what we would see is connected systems. Now, as I mentioned in the previous slide, a patient has the liberty to go to any hospital of his choice. That would essentially mean every hospital, every healthcare institution, be it a diagnostic center, to be a clinic, be a big hospital, they need to be talking to each other. And not only talking, they should be talking in the same language. And that's where we would see the next major change in healthcare. And as we speak, we have seen some instances of this happening already. If you see the case of Estonia, they have connected all their healthcare institutions together so that everybody talks each other and the patient can seamlessly go to any healthcare institution, and there he has a full history of what's happening to him or her. Similarly, in UK, to some extent, we have the NHS, which connects many hospitals together in their network. And even in India, with 1.3 billion population, there are plans underway in which every person will be getting a health ID. And with that health ID, the person can go to any hospital, any healthcare facility of his choice, and seamlessly get access upon consent to the records. And the consent, very important over here, is given by the patient. The patient can give the hospital or the clinician consent to see his or her data. The next major change is, with so much of data, it's huge, huge data, we have tremendous possibilities of AI. And the possibilities of AI in healthcare are massive. Currently, the pace of AI adoption is slightly slow considering the regulatory nature of medical devices, but this is something which is bound to happen in the future. You can imagine how much of advantage a radiologist would get if an AI algorithm can scan through thousands of radiology images and then scope down on the couple of images which are possibly showing malignancy or irregularity. From a triaging aspect, I think it gives amazing benefits in this case. But there are so many other applications of AI which gives tremendous clinician benefits, tremendous patient benefits. Overall, it's amazing to have such kind of technology helping humans. Now let us go through what are the challenges that we face in each of these aspects. So a disclaimer over here, the listed challenges are by no means exhaustive. There are a representation of the top few challenges which are possible. So going on to the first vertical of IoMT devices. IoMT devices would become like a commodity in the coming years. We would have almost 30 billion IoMT devices in the next couple of years. And since these are kind of become a commodity, even if 0.001% of these devices are vulnerable, a malicious attacker can search the web and launch an attack using these IoT devices. And not only that, these IoT devices essentially to make meaning have to be connected to a larger backend infrastructure. And if there is a vulnerability in these devices, they're basically entry point to a larger ecosystem. Okay, so let me explain it by giving the example of the Mirai attack. So what happened in the Mirai attack, which happened a couple of years back? We had distributed denial of service attack on number of servers like Netflix, Spotify, PayPal, and so on. So what happened exactly was we had a malicious worm being infected on systems which were there in home. For example, like baby monitor, like a refrigerator, web camera. So the malicious hackers found these devices, home devices, to be vulnerable and exposed to the internet. So they infected these devices with a worm. This is all without the owner of the devices even getting a hint about it. Okay, and these devices then become an army of bots who work on the commands of the bot master or the malicious, command and control center. And one fine day, the bot master decides to unleash his army. And that's when all these systems, all these IoT devices in people's home start the attack on servers like Netflix, PayPal, and so on, and which actually brought this server to a halt. Now, this is no mean achievement. Just to put in context, these servers handle petabytes of data per day. So to bring down these servers, you can imagine the kind of data, kind of requests from all across the globe that would have been generated just to bring down these servers. So it was a massive attack. And if these kind of things are not taken care, these kind of attacks would grow just because of the scale of IoT devices and the commoditization of these devices. These kind of attacks would grow. The next thing is about authentication. Typically, IoT, or for that matter, IoT devices have smaller footprint, and many times aspects like identity management and authentications are not really enforced. Okay. And I'll give an example to show what damage it can cause in a medical device. The example is of infusion pump. And this infusion pump was infamous for being the first device to be recalled by the FDA for cybersecurity reasons. And what was the issue? Not that it was actually exploited in the wild, no. A security researcher showcased as to how he could maliciously use this device to give uncontrolled amount of drugs to the patient. So as you know, infusion pumps work is to give controlled amount of drugs to a patient, which most probably could be a small baby, premature baby most probably, or could be possibly a patient, or for that matter, any patient who needs the use of an infusion pump. And over here, the limits of the drug delivery is critical for the safety of the patient. In this case, the security researcher reverse engineered the code of the infusion pump and found hard-coded passwords. Using these, he gave a command to the infusion pump to change the limits of the drug to be delivered. And in these scenarios, it's no longer a cybersecurity issue. It becomes a safety issue. So there is a very thin line when it comes to medical devices as to what is a cybersecurity and what becomes a safety issue. So these are some things that we have to be careful and cognizant about the threats. Going to the next vertical, the cloud. Yeah, cloud adoption has been in a very fast pace. Okay, some of the things that we really need to see is, if I put a cloud, if I put an application which was earlier in my data center to and port it to the cloud, application security still is the responsibility of the consumer of cloud. The application remains as insecure as it was earlier. Just by going to the cloud, security does not improve. So application security is there to stay, and it has to be taken care of during the development cycle. The other aspect with the cloud is, when we develop, when you port to the cloud, unlike in data center, where the entire responsibility of securing the infrastructure, the platform, the software lies with the consumer of the persons developing the software. But when we port it to the cloud, it's a shared responsibility of security, in which if I'm using cloud as a platform, as a solution, platform and the infrastructure, their responsibility of securing it lies with cloud service provider. The application layer security lies with the application. And this is where there is a lot of non-clarity as to whose responsibility is what. And depending on the deployment model, this responsibility also changes. And considering the massive adoption of cloud with so many applications and so many ways in which this deployment is done, the possibility of misconfiguration is high. And that's why in the last couple of years, we have seen hundreds of data breaches, not because the cloud was insecure, but because it was misconfigured. So the example which I would like to bring over here is about application security. And in this case, it's the use case of Equifax. As you know, Equifax is a credit rating company, and it had a breach in 2007 around. And what happened was, Equifax had a third-party software, Apache Struts, that had a vulnerability. But the vulnerability was already patched. However, the patch updates not applied on the system of Equifax. And the hackers basically detected this and entered their system using this vulnerability. And then the rest is history, because that's when they could really take out almost 150 million people's information. Okay. In this case, the point which I want to highlight is the application security could have many aspects, and that the responsibility lies with the application owner. It could have third parties, but the responsibility of managing the third party vulnerability still lies with the owner of the application. The next thing about cloud is APIs. Now, if you see, the rate of adoption of cloud is huge. And the reason we see the adoption is huge because a lot of platforms are being deployed on the cloud. These platforms are typical platform where various systems or devices can connect to them. And how do they connect to them? They connect to them via APIs. And this gives immense possibility for developers to design the system as per his need and so on. But it also gives an opportunity to the hacker if the APIs are not properly secured. There is possibility of hacking into the system just by hacking into the APIs. Okay. But apart from that, there is another very interesting thing about APIs. It's the design aspect of APIs. While designing APIs, we should be very clear how much data can the API give? Is there a possibility of the data getting misused? And the case in point over here I would like to bring is that of Cambridge Analytica. Cambridge Analytica is a political analysis firm which basically got information of Facebook users via an app called Your Digital Life. Okay, the job of Cambridge Analytica was to help, political parties in their electoral campaign. But what did Cambridge Analytica do with this data? So it got the data of about 300K Facebook users who used the app Your Digital Life, which is okay because the users had signed up for using that app, and it was kind of okay that their data was now with Cambridge Analytica. But what really caused the damage was Facebook at that point in time not only gave the information of the 300K users who used the app, but they gave about the friends of friends and their Facebook profiles via APIs to Cambridge Analytica. Via APIs to any API user, and Cambridge Analytica used those APIs. So by using those user base had now become from 300K to 50 million users, of whose Facebook profile information Cambridge Analytica had. And from these users, they could target a particular behavioral pattern of certain users, number of users, and possibly influence their voting patterns. Okay. So the reason why I bring this use cases, it's very interesting because Cambridge Analytica used the API as per the intended, but the intended use was so permissive in giving more information than needed that it got more data than it was supposed to get. And that's what is a high possibility even in healthcare systems, because the way we are going to get connected, we'll have a connection, hyper connectivity of systems. If we do not design the APIs correctly, there is a high possibility that, considering we have so much data in healthcare systems, we can give more data than what is needed, which can land us in problems. The next aspect is the connected systems. As I mentioned earlier, these are, hyper-connected systems with enormous number of entry points. And just because these are healthcare infrastructure, they also become critical infrastructure of a country or a company, whichever is using it. And once it becomes a critical infrastructure, the possibility of creating a denial of service attack is high, either from malicious hackers or nation state actors. Now let me take the Wannacry ransomware. So in 2017 again, we had a number of hospitals in the NHS UK which were not operational because of this ransomware attack. The way ransomware works is it will basically start its infection by maybe sending a phishing mail, and then it finds vulnerability in the network, either via unpatched system or systems which have reached end of life and they don't have a patch. Then it spreads to the entire network. And what it does is it encrypts your hard disk, and only after the user of the systems give the money, the ransomware will decrypt it. Now, considering that it is a healthcare system, there is a high possibility that the the healthcare system would lose the patient data almost maybe forever if proper backup has not been taken. And this becomes critical. And not only that, since it's a healthcare organization, it being not able to access the digital records for even a couple of days becomes a patient safety issue. Yeah. And that's the kind of impact a ransomware would have. And this is all the more important with these hyper-connected systems where the possibility spread is very high also. Yeah. Coming to the next point, these hyper-connected systems typically have to rely on a lot of third-party apps to develop. And how do we ensure that so many hundreds and thousands of third-party apps are secure? And that's what actually happened in this use case of Swift heist. So if you remember the Swift heist of Bangladesh bank is one of major financial money heists which happened via cyber security. Was in this case, Swift is a network which connects the banking systems across the globe to do international money transfers. Now, in this attack, the Swift network was not hacked. It was the application which was using the Swift network which was compromised, which gave to one of the biggest heists of the banking network. Yeah. Coming to the last vertical, it's AI. As I mentioned, the scope of AI in healthcare is immense. However, data integrity and trust are of paramount importance for AI to take off in the medical field. If the AI model works on data which is poisoned, the output cannot be relied on. And also, how do I rely on an AI model if I'm not sure if the AI model is already biased because of the data on which it has been fed? And what I wanted to also give as a use case as to what could possibly happen is, we had security researchers run AI algorithms on CT images, and selected images the AI algorithm picked and introduced malignancy in the image. And these images were shown to a doctor in flesh and blood to differentiate if the doctor can make out as to what is an actual malignancy image and what is a malignancy image caused by the AI algorithm. And it was done so well, the doctors could not differentiate. And that is the power of AI, which used in a good way, I think it has immense possibilities. Okay. The other aspect is privacy. As already mentioned, AI algorithms to work needs millions of data sets to work properly. Now, healthcare data is very costly. It's almost 10 times the financial data. Now, with such a high value on healthcare data, the possibilities of hacking this data for money is very high. And so also the concerns for privacy. And because of the concerns for privacy, the adoption and of AI algorithms in the healthcare field has been, not as much as it should have been. Okay, so this has been a whole laundry list of cybersecurity risks that faces. But yeah, this is to set the context, but I think the future is promising. So let's go to the next slide. So in the next couple of slides, we'll see how is the industry trending in terms of mitigating these risks. Again, a disclaimer, these mitigations are not exhaustive by nature, number one. Number two is some of the mitigations might be spread across one or more verticals seen. So there is always a possibility because the security principles remain the same. Okay, so let me go through the list of things that's happening to ensure that we have a more secure world and more secure healthcare ahead. First of all, for IoT devices, what is very key is secure updates. And as I mentioned, this is not only for IoT devices, it's true for any software. And why is secure updates so key? Because the mantra here is build to adapt. Today, I can create a perfectly secure software, but tomorrow there can be a vulnerability, new vulnerability out in the wild, which can make my 100% secure software vulnerable. And the only way we can address this is by creating a means of robust, safe, and secure channel for updates. And this should be also agile. Okay, that's very key in any software. The next one is product certification. Now, if I see IoT devices will be a commodity, and there will be millions of these devices. Now, who is responsible for assuring the security of the device? Do we expect the consumer who buys it to ensure that the device he buys is secure before buying it? Don't we think it's too much of a responsibility on the consumer? He has to take care of securing his home network. He has to be aware of all kinds of phishing attacks and so on. That has to be also responsible for security of the product which he buys. I think that's a bit too much to ask from the consumer. So what would happen is, like how we saw the CE marking change the world. When we see a device with CE marking, we are assured of the safety of the device. Similarly, we will have product certifications, product software certifications also, which will assure us of security robustness of this device or software. The next one is standards. I would say standards and standardization. As we speak, the number of standards being developed for IoT. There were some in the earlier, but we have seen a gained momentum on this. And not only this, we'll see an increase in standardization of platforms. With standardization of platforms, we'll see standardization of protocols being used. We'll have out-of-the-box identity and authentication management modules, which will help products leverage these tools from the platform and be more secure. So standards and standardization is the way forward, and we have already seen a lot of activity happening in this area. The next aspect is about cloud. One of the key things on cloud is the agility. We have seen some of the cloud companies releasing almost 100 releases per day or more than that. Yeah. And over here, the mantra is build to adapt. We do not build the entire stack and then release in a big bang way, but instead we do incremental builds and release. Now, how do we ensure that the release happening number of times a day are secure? The only way to assure it is integrating security in our development lifecycle. That is maximizing the automation of security tools in the development life cycle. Okay, so that security and development can walk hand in hand, and security no longer needs to stop development for the release. Instead, they are cooperating with each other for the release, and that's what all DevSecOps is about. The next thing, software bill of material. This is something which is gaining importance. Like how we see a medical pill will have all the ingredients of the pill written. Similarly, going forward, a medical device will also have all the ingredients, in this case, software ingredients or hardware ingredients, mentioned very clearly. And this is important because our software is as secure as the components it imbibes. So if there is a vulnerability in a third-party component, our software is also vulnerable. And we, as medical device manufacturers and people as consumers of this device, need to know what exactly has gone into this software. And this is something which is going to come. FDA is already having draft guidelines on this, in which device manufacturers have to list the software bill of material along with the product release. The next, which I think we already touched upon earlier, is shared responsibility. On cloud, it's very clearly a shared responsibility between cloud service provider and cloud consumer. So what we would see in future is we give me a second, please. We would have more tools. We would have more tools to monitor the applications on clouds, hosted on clouds, and the cloud service providers will increasingly give this as a service, and this is something that should be used. And of course, clarity on who is responsible for what is of prime importance. Connected systems, and that's when zero trust becomes very important. Zero trust is not a technology, it's a philosophy in which it's said that never trust a system, a user, a session, a device, always verify. Okay, and there are a lot of things associated with zero trust in terms of identity management, in terms of access control, in terms of conditional access authorization, in terms of network segmentation, and so on. And this becomes paramount importance in these hyper-connected world. And this is an ever-evolving thing. It's not just that we do it once and then it can be forgotten. It has to be continuously maintained. The next one is monitoring and incident management. For these kind of hyper-connected systems, very crucial to monitor for possible attacks or vulnerabilities. And in case there is an issue which has come up, incident management, how proactively can we contain the incident, becomes very important. And again, for such a hyper-connected system to work, interoperability is the key. Everybody has to speak the same language while communicating. And not only that, standards for the systems which join the network, standards for the device who join the network, standards for the users who join the network becomes key for these kind of hyper-connected systems. Otherwise, there is hardly any kind of entry criteria without these standards, which will enable a user device system to enter this kind of ecosystem. The last vertical is AI. As we mentioned, AI, data integrity becomes the key that establishes trust on the AI model. Privacy, as we saw earlier, could be an inhibitor for adoption of AI in medical industry. However, if privacy is done right, it can be an enabler. For example, in GDPR, we see GDPR as a regulation and more systems adopting it. They have to adopt it if they're operating on EU nationals or in EU. So these kind of regulations enforce that the systems are compliant to these regulations and thereby also enable trust on these systems. And not only that, there are some technologies which would actually, when done right, would help further AI in healthcare, like the privacy-preserving AI. What happens in privacy-preserving AI is the AI algorithm does not need to own the data or have direct access to the data to work. It can have a contract with the data source, which exposes certain APIs. And the algorithm just needs to make those API calls. And as long as it gets the right answer for his calls, it is good enough for the algorithm, because the algorithm as such is not really interested on the details of the data. It really wants to see it in a large scale and see what are the typical trends, what are the things that's happening on the data on a large scale. And that's what would help actually adoption of AI in healthcare, because more and more people will be willing to share the data because there is no risk of sharing the data. Okay, and again, standards and interoperability will be the key. This is to further the adoption of AI. And as we speak, we have seen number of organizations working on this. We have seen NIST, we have seen FDA, we have seen IMDRF working on standards and guidelines for adoption of AI in healthcare. So over here, the key takeaway is the future of healthcare will become a system of engagement centered around the patient. It would give rise to connected systems and would further enhance the adoption of AI. What are the cybersecurity trends that we see? There will be an increase in standards and standardization. So in terms of standards, we see emergence of a number of standards, and also standardization in terms of the protocols used, in terms of common components being supported by the platform, which will ease the development of various healthcare components. The mantra remains build to adapt, be it DevSecOps or be it secure updates. It's about how securely, how fast can we update our systems to protect them from being vulnerable. Third is to establish trust. Trust on data, trust on system, trust on devices, trust on users, trust even on the sessions being enabled. And having done all that, we still have to be vigilant, being able to monitor the system that we have created for possible threats. With this, I come to my last slide. Objects in the future are closer than they appear. Many of the things that we discuss are already happening as we say. And thank you for being so patient and for all the hearing. Thank you so much.
Minati, thank you so much. We do have some questions from the audience and a little bit of time before we have to reach the top of the hour. So I'll start with, what is the role federal government should play in connected ecosystems where patient data is managed centrally and accessed by different entities?
Sure. Thank you. So a very good question. So federal government, of course, it depends on the country we're talking about, but the basic responsibility of the federal government would be to lay down the policies, the framework, and the regulations in place so that whichever actors join these kind of infrastructure knows what are the entry criteria and what are the obligations that the entity has to join this network. So it is mostly about laying down the policies, framework and regulation. And these are for countries where the federal government does not manage the healthcare organizations directly. For countries where the federal government manages the healthcare organization, the ballgame is totally different because it has much more skin in the game than just laying the regulations and entry criteria and policies. Thank you.
And of course, and a follow-up to that question, how will globally evolving privacy regulations be different in helping to strengthen security measures for personal data?
Sure. So was the question, how will it be different?
Yeah, that is what's here from. So how will it help? I think as they evolve and become different, how will that help to strengthen security measures?
Yeah. So now this is very interesting. Thanks for this question. Okay. Now, if I see privacy is about protecting the data. And how do you protect the data? It is only by security measures that you can protect the data. So typically, privacy says what is to be done. How do you do it is to be enforced by security. So if a system is privacy-wise robust, that means there is a lot of security controls built into it. And we see a lot of countries following GDPR model in enhancing their privacy policies. So which is a good way because we'll have a larger global adoption of privacy regulations across the globe.
Great, thank you. Another question from the audience. What are some ways we can minimize user error security risks on the consumer end of cloud software?
Yes. And that is somewhere I think we should greatly leverage on the services which are provided by the cloud service providers. Of course, we should have our own inbuilt controls, checks and measures to see that misconfiguration is stopped. But what is readily available as a service is something that we should highly depend on.
Excellent. And another question from the audience, specifically when we talk about the future proofing of healthcare IT, what are some strategies and tips you can offer for, we've taken a look back at what has been happening and looking forward, what are some things that folks should be doing?
Yeah. So one thing which we have to be, I think we did mention the 4 pillars. I would come back to that. First thing is establishing trust. And that's the philosophy behind zero trust frameworks. So there has to be a lot of focus on identity and access management. There has to be a lot of focus on how do we do network segmentation and how dynamic can the network segmentation be. And thereby, if it has to be dynamic, it has to be typically a software-defined network. Okay, and also about if I'm going to give, restrictive conditional authorization to a resource, the controls should be closer to the resource in allowing who has access, who doesn't have access, or at what time of the day the entity has to have an access or not. So the access controls also become very key in these kind of systems. So the other thing is with respect to trust of data. Data integrity measures would be key. How do we ensure privacy of the data, be it by using technical means like privacy preserving AI or by de-identification and anonymization? How do I ensure that the privacy of the data is key? The other thing is, while product development, the agility in which we integrate security in our product development defines the robustness of the product which is being developed. And that's where automating the security tooling into the development lifecycle becomes the key going forward. And of course, traditional monitoring, incident management remains, and automated ways to detect incidents is also very important. And as we speak, there are a lot of technology coming up, again based on AI, which are able to see a change in behavior in the network and say there is a possibility of malware or an attack. And also we have the ability to contain that kind of attack.
Excellent. I think we have time for one more question. So can you talk a little bit about why a medical record is more lucrative in the black market than credit card data?
Sure. Thank you. So if I look at a medical record, there are two attributes to it because of which it becomes more lucrative. The first one is it has a lot more data than a financial record. So for example, a medical record will have a person's personal history, age, age, place of birth, gender, and so on. Second is, it'll have his medical history, it'll have his financial records, and lot of other connected details like social security numbers or his unique identifications and so on. That's the first reason. The richness of the data makes it more lucrative. The second one is, some of these data are permanent in nature. And even if a person wants, he cannot change it. For example, his age. Whereas in a credit card hack, he can renew or get a new credit card tomorrow, but a medical record in many cases are permanent. So because of this, the value of a medical record is much more than a financial record.
I want to try and squeeze in one more question here before the top of the hour. It's about supply chain, and one of our listeners is asking, how can healthcare consumers verify that providers are compliant with the best practice standards described in the presentation today?
Sure. No, thank you for this question. This is something that I think haunts everybody. Okay, so one of the things that we do, of course, ask for details of their compliance details in terms of standards. What are the compliance requirement they have met? What is the due diligence they have done in terms of, in the security processes, if they have security certifications, if they can show reports about security pen testing and so on. And also another important thing is, if I'm buying a software from a third party, how do I know the components of the third party? And that is where it's a new thing, but that is something which has to be enforced. We ask the supplier to give us, in a standard, industry accepted standard format, his software bill of material. So along with all the other traditional things which we have been asking, this is something which we have been increasingly asking our suppliers.